we're going to identify and graph the polar equation r equals 4 plus 2 sine of theta. For identification purposes, this is a Limacon without an inner loop. I'm going to show you the form of that in just a few moments. Right now, let's do the test for symmetry because we have to graph this. So we're going to check for condition 1, condition 2, and condition 3. For condition 1, we want to test symmetry with respect to the polar axis. If we substitute in our theta with negative theta, and we get back to the original equation, then it's going to be symmetric to the x-axis. Basically, this is an even-odd test. This is an odd function, so you pull this negative out front, and we get r equals 4 minus 2 sine of theta. Since sine's an odd function, it's not going to be symmetric with respect to the polar axis. So this means this test fails. All right, so let's check with symmetry with respect to the line theta equals pi divided by 2, which is the y-axis. All right, for that, we're supposed to substitute in our theta with pi minus theta. So we have r equals 4 plus 2 sine of pi minus theta. Now this follows our sum and difference formula for sine, which is right here. And so we're going to expand this. I'm going to move it down a little bit. We get r equals 4 plus 2. Now expanding this, we get sine of pi times cosine of theta minus cosine of pi times sine of theta. All right. Sine of pi is 0, so this just zeroes out. Cosine of pi is negative 1. So this is going to end up being positive sine. So we're going to get r equals 4 plus 2 sine of theta. Since it is equivalent to my original equation, it means this test passes. So our graph is going to be symmetric to the y-axis. The last test is with respect to the pole. That just means you substitute r for negative r. And if you get back to the original equation, then that test passes. But it doesn't. So this test fails. The only time this test will pass is if you have your r squared. If you have an r squared. So like this form. So this is our Limacon without an inner loop. It has this kind of shape. And the reason it's a Limacon, it almost looks like the cardioid. The cardioid, the terms are the same here. But a Limacon, our A is 4 and our B is 2. Since 4 is greater than 2, it means it's without an inner loop. If it was reversed, it would be with an inner loop. And if it was the same, it would be a cardioid. Almost looks like a cardioid. I say it looks like an apple. The cardioid is more of a heart shape, but they're almost the same. So let's go ahead and graph it. Since we know it's symmetric to the line theta equals pi divided by 2, we're going to assign values to theta from negative pi divided by 2 to pi divided by 2. All right, that way we don't have to crank out so many values. And we just can go by symmetry. So we're going to start with negative pi divided by 2, negative pi divided by 3, negative pi divided by 6, 0, pi divided by 6, pi divided by 3, then I'm getting too close, pi divided by 2. I'll put it here. All right, and we are going to find our r value. Our r is 4 plus 2 sine of theta. So substituting in our values, at negative pi divided by 2, we're going to get 2 for r. Negative pi divided by 3, that's going to be 4 minus square root of 3. That's approximately 2.3. Negative pi divided by 6 gives me 3. At 0, we get 4. At pi divided by 6, r is 5. At pi divided by 3, we get 4 plus square root of 3. That's about 5.7. And at pi divided by 2, we get 6. So let's plot half of the graph and then use symmetry to plot the rest. At negative pi divided by 2, that's here, we're at 2, so we go out 2. At negative pi divided by 3, that's where we're at, and we go out 2.3. So just a little bit out here. All right, and then at negative pi divided by 6, we're at 3. So we go out 1, 2, 3 is right there. At 0, we're at 4. 1, 2, 3, 4. At pi divided by 6, we're at 5. 1, 2, 3, 4, 5. And then we're close to 5.7 at 5. Whoops, right about here. And then at pi divided by 2, we're at 6. So that's going to be 1, 2, 3, 4, 5, 6. All right, so let's connect these. See our shape. And now we know it's symmetric to this line, theta equals pi divided by 2. So we're just going to use symmetry and go back around. So here we'll be at 5.7. Then we're going to be at 5 here. 1, 2, 3, 4, 5. At 0, we're going to be at 4. So 1, 2, 3, 4. And then we're going to be at 3. 1, 2, 3. Then at 2.3. And then back to here. So we can continue on. Now it's a lot easier than trying to crank out points here, having to use your calculator and stuff. And there it is. Almost looks like a circle. Thank you. Have a nice day. Bye-bye.